here, how to find the inverse of a function. This means inverse. This is the notation for inverse. Anybody remember how to do that?
Make it wiser. Percent equals to negative.
Make this a y,
Yeah,
do
yeah.
that first. So f of x is the same as y.
You flip x and y.
Switch your variables. So x equals y plus 2. And then yes, y by itself. So this is your inverse, which makes a lot of sense. I mean, I went through all the steps, but if the original function just takes the number and adds 2, then to undo that, we'll just subtract 2. That's what the inverse does. So, just to make that a little clearer, look at your original problem. If you pick a number like 5, the original problem, if we let x be 5, then y will be 7, correct? In the inverse, if we let x be 7, y turns out to be 5. Inverses undo each other. Okay? How about b? We want to find the inverse of b. Now, some of you might be able to do this in your head. But for those of you who can't, or don't want to go to all that trouble, let's go through our steps. So remember what our first step was, switch the variables. And then the y by itself. So we'll do the subtract 1, divide by 3, and there it is. There's your inverse. Easy check, not a proof, but a quick easy check. Pick a number like 5. If you put 5 into the original problem for x, what do you get? 16. Now take that 16 and put it in here, and what should happen? You should get 5. We do, right? If you put 16 in here. That's a quick check, not a proof. We'll talk about proof later on. That's a check. All right, now we got a harder one. C is a little harder for you. All right, so here's my problem. Replace f of x with y. So I did that. Now what's my first step? Switch them. Switch them all. So you're going to have x equals 2y minus 3 and 5y plus 1. Now what do you think? Exactly. She says clear this denominator out. So I'm going to multiply this over here. So I multiply this over here. Good. Now what makes sense? Okay, let's talk about that for a minute. Eli says I can add 3 and then divide by 2, and then it would have y by itself. And he's right, except what?
There's a lot of that.
There's another y. That's trouble. So, instead of doing that, I'll distribute here. And then I'm going to flip-flop the start with that, I distribute it, and then I move this over and this over. My goal is to get y by itself, so look what happens. And I take a y out now, and when I do, I only have one y now. Eli's issue was he had two y's. Couldn't deal with it. So now we put the y's on the same side, factor it out. What's y equal? Exactly right. There's your inverse right there. Perfect. There it is. Makes sense to you? All right, let's look at the next one. Remember, you gotta start by switching your variables. That's what inverses do. But I gotta get y by itself, so what do you think we could do with this one? Square both sides? So x squared equals y minus 4. So x squared plus 4 equals what? So your inverse is x squared plus 4. What in the world are we going to do with e?
We are going to
Find slope.
switch X and Y.
Switch all the x's and y's. So your inverse will be the point 2-1,
Yeah.
the point 4-3, 6-5, and 2-7. Because when you find an inverse, what is the very first thing you do? Switch y and x. If you have an equation, then you have no work to do. But in this case, all we got is points. We just switch y and x. That's it. Number 2 is a vocabulary question. Have you ever heard one-to-one? One-to-one functions? One-to-one? One-to-one means that a function, or excuse me, that a relation is a function and its inverse is also a function. So, if something's going to be one-to-one, it has to pass the vertical line test, and it has to pass the horizontal line test. What? What am I talking about? Well, remember, to be one-to-one, f is a function, f inverse is a function. That's what it means to be one-to-one. Now, if something is a function, it passes the vertical line test. We know that already. So if something doesn't pass the vertical line test, it's not going to be one-to-one, because it's not even a function. Now, I want you to think about something for a second. See this shape right here? It is a function. But if I draw a horizontal line, notice that the horizontal line hits twice. Now keep in mind, that point might be -2, 3, and this point might be 4, 3. So this might be a function, the blue thing is a function, but its inverse is not. Because if I switch the ordered pairs, now the x's are repeating. So that's where we use the horizontal line test. So if someone wants to know if you're one-to-one, do the vertical line test and the horizontal line test. You gotta pass both. So is A one-to-one? No. And if you had to explain, you would say it fails the horizontal line test. Is B one-to-one? No. And if you had to explain, you would say it fails the vertical line test. Is C one-to-one? Yes. That, which function is that, by the way? Square root. And that is one-to-one. What function is D? And that one is also one-to-one. If I were to get tricky and ask you a question like, is y equals ln x one-to-one? But I didn't give you a picture. Could you draw a picture? What does ln x look like? That, right? This is your logarithmic function. Is it one-to-one? Sure is. All right. Now we are going to actually prove that these things are inverses. Now, you aren't going to like this. You're going to want to do it other ways that you can. So we are going to talk about the formal way that we prove two functions are inverses. Play by the math rules. Formal math way. Here's what you're going to do. You're going to build this composition, and you're going to build this composition. Now, these two are indeed inverses, so you're going to see what happens when we build these compositions. So what does this mean? You did this on your test. Some of you more successfully than others. You take function g and plug it into f. So we're going to take function g and plug it into f. So 3x minus 2 over 3 plus 2. Yeah, simplify it. Won't these cancel?
Yeah.
So I'm left with x minus 2 plus 2, which is just, that's what happens. When you build the composition, everything should cancel out and leave you with just x. So this one says take f and plug it into g. So 3x plus 2, that's f, minus 2 over 3. So I'm plugging this into here. So these cancel, and I'm left with 3x over 3, which is x. If the two equations you're concerned about are indeed inverses, this will happen.
Has to be both.
Has to be both. So you're going to do this and this. All right, let's try B. So right now, you are thinking about, in the order you do these doesn't matter. So I wrote F of G and then I'm going to do G of F. But it doesn't matter what order you do those. It's got to do them both. big, it's gonna look yucky, but everything cancels out, remember? So it's not gonna be so bad.
Would we have to explain it and say like, yes, we got X for both of them? Like how would we explain
That
it?
probably wouldn't hurt. Just make a concluding statement since f of g of x equals x and g of f of x equals x, where f and g are inverses. That's a good idea, always to put some kind of conclusion with the point. All right, here we go. This says we're going to plug g into x. So this is going in here. I know it looks messy, but man, 2, 5x plus 7 over 2 minus 7 over 5. What's going to happen right away? Right away, those are going to cancel. So now what do you have on top? 5x plus 7 minus 7, which is 5x over 5 is x. If they are inverses, it's always going to be simple because everything's going to cancel. If stuff doesn't cancel, then they're not inverses. All right, now the other way. So now we're going to plug f into g. So 5, 2x minus 7 over 5, plus 7. Same thing gonna happen, these are gone. 7s are gone, so I have 2x over 2, which is indeed x. Since both my compositions turned out to be x, that means these things are inverses.
So if you like did the first one and did X,
Yeah, they would stop. Good point. Michael says I have to do both. But if the first one, let's say the first one, stuff didn't cancel and you were left with x plus 3, then you're done. Because it doesn't really matter what happens down here because they both have to.
So once you
Yeah. Once you don't have it, once you don't get it.
thank you.
All right. We're done at 40, right?
Yeah.
All right, let's do a couple more here. I'm gonna hand this X out because of you,
And we're gonna realize that we made huge
and
mistakes.
I made a bunch of mistakes. Used the wrong key. All right.
We typed in chance test for mine.
I think my test is it.
Now? Kill for that.
All right, so in section 1.5, there are 2 main topics. Inverses, we've already done some work with inverses. And then these things called parametric equations. Parametric equations are a system of 2 equations that involve a third variable. So we have our x and we have our y, but we also have this thing, it's called a parameter, t. And they're used a lot in physics when you want to locate an object at a particular time. So, for example, the first question says, find the points determined by these t values. So I just organized it, I just set up a t chart. And my first t value is -3. Well, if t is -3, then x is -2. If t is -3, on my arithmetic, is y 3? That's all. It's that easy. find the direct algebraic relationship between x and y by eliminating the parameter. That's a mouthful. But what it means is, take these two equations and eliminate t. So in other words, you want to have only one equation with x's and y's, but no t's. Does anyone have an idea how we might do that? Come on. Well, I can't really set them equal to each other because they're not equal to each other. If that had been y, then I could set them equal to each other. No, but that's a great guess. Don't I know that t equals x minus 1? So could I take that and plug it into here?
Yes.
Oh, not there. And if I plug it into there, the t's are going to be gone. And all that's going to be left is one equation with x's and y's. So I'm going to multiply this out. So this is a FOIL, remember? Don't get lazy. That's a FOIL. You guys let me get away with something. Well, this is the 24. I put 4 in. I'm supposed to forget. Don't call me on it, Riley. Here it is. Here is your direct algebraic relationship. That is your equation. Linking x and y. All right, now we're gonna sketch that.
Down one.
So, he says, I don't need, this isn't a big deal, this equation's easy for me, because I know that it's a parabola down one. You also have, though maybe this one worked out nice because these canceled, but what if they didn't? What if you had another thing in there that was messing everything up? Remember, you already found the order pairs. So -2, 3, -1, 0, 0, -1. You have points here. You
So
just
this is
plot
just
them
back here.
and connect them. Right? Now, get out your calculator. Because we're going to go ahead and graph parametrically. So we are going to graph, not this. This isn't what we're going to graph. We're going to graph these guys right here. All right, so we got our calculators out.
Where's the T?
Step 1, go to node. Node.
Oh.
Choose, go down the list.
Yep.
Find PAR, parametric, and highlight it. Because you are going to be graphing with parametric equations.
Yep, click there.
So, right, when you turned your calculator on, FUNC was highlighted, you're going to go over in that row and highlight parametric.
Alright, I highlighted it. I did too much. It's like down
Mode.
Green mode. Come down here, where it says parametric. Right there, yeah. used to look like y1 equals y2 equals. Now it says x equals and y equals. So you're gonna put in t plus 1. If you use your x button, your variable button, now it'll say t and not x.
Whoa.
Right?
That's awesome.
Plus 1. And then t squared plus 2t. When you put a variable into your calculator, you're always going to use the variable button. But depending on what mode you're in, that will determine what variable you get when you press the button.
And then
Okay, and then you hit graph. Yep.
should I zoom 6 that or no?
I would.
Zoom in.
He said zoom 6.
That's like let's zoom in 6.
If you're having a bit of an issue, let's go to window. Press window. Now, here are the T's that we put in. Right?
Yep.
So maybe to give ourselves a little cushion, let's let T min be -5 and T max be 5.
Is it okay if it's a greater than 5?
And then T step, we'll talk about this later, but for now, just make it 0.1.
I like how it's 1.1.
And then what about our X's, you guys? Maybe our X's could be,
Wait, what's this? 20?
well, what's our smallest step?
-2.
So why don't we do -5, just give ourselves a little bit of cushion.
And then 20.
And then maybe, I don't care.
I like 20. That's 20 for the cushion as well.
And then Y min,
That's a 20.
It's like
Well, we do Wyman too. Are we doing the same? Like,
I did. It really doesn't matter.
for Y, we should do the
But
same.
I wasn't sure what you were seeing
Yeah, Y was just like
when you first did it, but now you clearly see your problem, right? Now, I was not a genius person. I simply looked at my data, right? My X's are from -2 to 4. So I just want to have X's. Jimmy, what's your calculator?
I don't have one. It's at my house.
Wow.
That is not acceptable.
It's just at my house. Don't have it here. No, it's not here.
We have to have a
You should have
calculator.
hidden.
Okay, understood.
All right, so we got a graph. Okay, now, I looked at Eli's picture. His didn't look like mine because we chose a different window size. For some reason, he wanted to go to 20, which is fine. I didn't, and so my picture is more condensed than his. It doesn't matter. As long as you're plotting these points, you're going to see that picture. So X's, Y's, and then T's right here. Remember, kids, your calculator is in parametric mode. So if you are trying to graph a regular equation, it's not going to work. You have to change it back
You go
to
to mode.
function. All right, let's do another one. Repeat number 4 for these equations.
Oh, so do we even put anything down for D then?
Well, I would put down the sketch I got.
Okay, okay.
All right, x equals 2t and y equals 3t minus 1. All right, so the first thing we're going to do is generate some points, which, if push comes to shove, can help me graph this by hand, because I have the points. All right, so -3, -2. Here are my points. Don't just lie to me. How do those look?
Personally, I think they look good.
Yeah, but you told me how last time. Right? You matching those? Holden doesn't know, he's just copying them down.
It's way too quick. -3 was 6 and -3 was 9 minus 1 is that thing.
Find the direct algebraic relationship between x and y. So that means get rid of t. Get rid of t.
How do you know which one to try to cancel out? Like,
Because you're
What do you
in the
mean?
perimeter.
Like
T
on the
is what
first
it's
one?
gonna have to cancel out. T's gonna have to be gone.
so it makes, but like, how do I know which equation to do?
Oh,
Like
it
extra
doesn't
y.
matter. You just pick one. This is like regular substitution back in algebra 1 class. You just pick one. I mean, this one I'm gonna have to, if I solve for t, it's gonna be like 2 steps. This is only 1, I'm gonna divide. So I'm gonna say t is x over 2.
Yes.
But it'll work either way. And then I'll plug that in here. So y equals 3 times x over 2 minus 1. So y equals, we have x minus 1, I think.
Then put that in our calculator.
Don't matter put that in our calculator.
Then put that.
You know what this looks like. What is this?
Well, this just gets me back.
That's a linear equation.
A linear equation with a y-intercept at -1 and a slope of 1, 2, 3 over 2. 1, 2, 3 over 2. So when I do this on my calculator, I should be getting a picture that looks like that.
When we do it that way.
Yeah, look at that. I mean, that's the picture.
That's for C. That's for C.
This is when I graphed it as an XY equation. Now I'm going to put it into my calculator.
So hypothetically, can we use the
Yeah, but now if you're learning how to graph parametric.
I got it. I got it. Stop.
I just be if I'm on a test, I'm kind of like piecewise.
Mine stops right here.
Did you get a nice little line?
Yeah, mine stops.
Well, why does it stop?
Piecewise.
Because when you set up the problem, you said we're going from t is -3 to t is +3, right? In reality, does this line keep going?
Yes, yeah.
Yeah, so it graphed exactly what you told it to graph. If you make t more, so -10 to 10, it'll graph more than that. -100 to 100, it'll graph even more than that. But we were specifically only looking at those.
So if we made the window smaller, it would just look like
No, if you made the window bigger.
Oh, okay.
Yeah. All right, one more problem, and then we're going to look at our test. Again, don't come running up here saying, my calculator doesn't work. Your calculator is in parametric mode. You need to go to mode and change its function. If you want it to work, it makes normal sense. All right, sketch the inverse. So here is our original problem. And we are going to sketch the inverse of this. You guys know how to do this. Remember when I gave you on one of those problems, you had a list of ordered pairs? And I said, find the inverse? All you did was what? Flip them over. So if I'm going to graph the inverse, then instead of the point 1, negative 2, 0, I'll do 0, negative 2. And instead of negative 1, 1, I'll do 1, negative 1. 0, 0 won't change. So there's this. How am I doing it? I'm switching my order pairs. So this is 1, negative 1. So negative 1, 1. This is 2, negative 1. So 2, negative 1 would be negative 1, 2. And then 3, 0 would be 0. There it is. Notice that it's the same shape, but everything was kind of sitting on the x-axis originally, and now everything is sitting on the y-axis, which makes totally good sense because you switched x and y. All right, go ahead and graph the, and we'll be done. Graph.
Those all points.
All right, how's that look? Everybody got that? All right, 1.5 is due on Tuesday.